Thank you, Dustin. It's a pleasure to be at the third symposium that we have done in the last few years. And I'd like to thank Arla and TreePeople for giving me the opportunity to be able to participate in this, I think, very much needed project. So this morning, believe it or not, when I was thinking about my title slide, I always wait for the last slide to be the title slide. And I'm like, well, I'm going to look for some photos of best management practices, soils, and all this stuff. And then I thought, well, what's an example of a worst management practice? You know, something that kind of shows you the other side of the coin. Well, the Dust Bowl, 1930s, came to mind. And when you think about a confluence of poorly managed lands with drought, so climate, source kind of thing, we had this total environmental disaster, not only for the environmental systems, but also the social system. I mean, farmers were, there's a great mass migration of Americans within our own country, 500,000 people because of this natural disaster. And of course, the very famous quote by Franklin Delano Roosevelt, "A nation that destroys soils destroys itself." And so when you think about the poor practice of, well, the idea of turning over and eliminating prairie grasses, deep-rooted perennial species, replacing them with annual plants and disturbing the soil every year, and if you don't do that smartly, you're setting yourself up for disaster. And all it took was a drought for that disaster to occur. So with that in mind, I wanted to start off, I always like to talk about what I call the importance of cities and soils to Homo sapiens. And of course, the figure on the right, we're all pretty aware of this. Soils have a global importance, right up there with the atmosphere. As far as carbon cycle goes, it's important for biodiversity. I'm not going to go into all that. I think most of the folks on the phone on the seminar today understand that. But I wanted to put in a pitch for cities because, with 9 billion people expected to be on the planet in the next 20 or 30 years, maybe 40 years, we're going to have to find a place for them to live. And I would argue it's much better to put people in densely populated situations rather than spreading them out in the landscape, because we're going to need those lands to produce food, fiber, and maintain our natural ecosystems. And so cities are the answer. But with respect to worst management practice, I think the urban conversion is more like a lost opportunity than a worse WMP. And I'll get into that a little bit as we go along here. But cities are the answer. And we have to find a way to build sustainable, resilient cities. And I see it as an opportunity. And again, I'll tell you why. So again, there's the ecological importance of soil in an urban context as well. And I would argue that soils are probably attain a higher importance in densely populated areas for lots of reasons, which I'll get into. But we have the usual nutrient cycling, carbon storage, plant health, water cycle. We're all familiar with that. In an urban context, sink for pollutants, substrate for built structures comes in, flow path for storage of nutrients and so on also are important. But what's really important in my mind is that there's an awful lot of people that live in urban areas and thus are intermingling with urban soils. 80% of the population of the United States, and I think it's up to 65% of the world population, live in cities. So there's this close juxtaposition between people and soil that I think adds to the importance of urban soils relative to, nature. But there's also a social ecological importance to soils that often gets discounted as well. And And I always like to show this slide of working ecosystems, eco-engineered ecosystems, and amenity ecosystems that you find in urban areas, in which soils are the foundation for many of the services that are provided there. So it's not only the ecological function of these systems, it's also the social functions of these systems and that close proximity with people that really makes soils important. However, when we densely populate people on the landscape, there's a trade-off. And so a lot of the natural ecosystem services we get from a natural ecosystem, we lose as we densely populate the landscape. And that's because we have pollution sources, we fragment habitats, we have the impervious and built structures, we disturb the soils, disrupt nutrient water cycles, all that kind of stuff, which is kind of obvious, but there is this trade-off. So we're able to get densely populated communities, cities in the last 10,000 years or so, but we're diminishing the services in the local area as we do that. And our solution to that has been gray infrastructure. And I'm not going to get too much into this, but obviously the Romans are pretty good at this. They had aqueducts, they were densely populating a city. They needed fresh water. Well, they brought it down from the mountains. They had excrement they had to deal with. Well, they built sewers, the Cloaca Maxima in Rome is very famous for that. And later on, others, as we had the Industrial Revolution, and we're building industrial cities. New York City would be a good example of taking water down from the Catskills and so on and so forth. And so if anybody knows Edwin Chadwick and what he's known for, you get a prize later at the end of the symposium. But we developed these, what they call sanitary cities, and mostly done with gray infrastructure, primarily with gray infrastructure. So the engineers are way ahead of us. They've been doing this for a long time, and they do a pretty good job of it. However, gray infrastructure with respect to sustainability isn't very good. It's imperfect and it degrades. I'm not sure if you're getting this in LA yet, but I'm from New York City area and worked in Baltimore, old industrial cities, United States. The infrastructure is falling apart, and that includes sewage systems, everything. And so that degradation is really hard to go back and fix. And we kind of have to live with it, so that original idea of a gray infrastructure being there forever, comes into question. But it also requires intense use of resources. Concrete's the number one, built structure material, and it's an awful lot of emissions involved with concrete as an example. But there are also lots of side effects from an environmental perspective that aren't very good either. And so obviously engineers are really good at getting water off a site as quickly and the shortest distance possible into a drain. And that drain, of course, goes in the stream. And we get these urban hydrographs, which, a lot of people know about. This isn't new information. But there is a side effect from all this that has impacts, and often those impacts are moved downstream. So they take care of the problem in the parking lot or the surrounding landscape, but they're giving their problem to somebody else. And the other thing is, probably more important for LA, is that there's less available water for plants and it's certainly not very good for the ecology of these stream networks that we find in urban areas. So the alternative approach, and again, this is a no-brainer, to realizing the potential of these urban areas and be able to densely populate them in a sustainable way, and one that's resilient to rapid changes in the environment, are sustainable cities, obviously, but using natural solutions. And again, this is a term that's been used a lot in recent years, but we often think about natural solutions. We think green. We don't think about brown infrastructure, which is the soil, and also the blue infrastructure. And they'll show later that we need all three. And it results in smaller footprints, less emissions kind of thing, healthier environments for people. And enables us to pack people together but at the same time, preserving their environmental health. So I mentioned there are trade-offs as we urbanize landscapes. I wanted to get a little bit more into that, and I wanted to use the agriculture example. And this is a great paper by Foley et al. 2005, where they looked at the trade-offs of ag land use change. And you can see on the left the natural ecosystem, and they call that a rose diagram. And those rose diagrams show various ecosystem services that come out of that system. Obviously, crop production is pretty low, unless you're Native American and know how to, you eat acorns and stuff like that. So we intensively convert that to cropland, and you can see, yeah, that does real good for crop production, but you lose all of these other services. And so the idea then is to develop crop systems in which you get everything with the restored ecosystem services. And we can think of that, and Dustin talked about this, multiple functioning landscapes. The agricultural cropland was real good for producing crops, but that's pretty much the only function we were getting out of it, and actually might even be getting some dis services as well. So how do we get over these trade-offs? Well, we can adopt different agricultural practices. And so this is a keystone paper that came out in Science in 2002 by Robertson et al. The Kellogg Biological Station LTER, which is the only agricultural LTER, long-term ecological research site, in the United States at the time. And they showed that through different cropping systems, you can reduce the emissions. Those are carbon CO2 equivalents on the axis, compared to compared to the old conventional system. So there are ways of getting around these trade-offs. And so I would also say that in urban areas, we could do the same thing. Again, we have a natural system. We convert it using gray infrastructure, and we get one or two different services out of that. What we really want, and again, Dustin mentioned multiple function. I'm going to bring in the idea of hyperfunction, because you can, if you think about an urban landscape with impervious surfaces and buildings and structures, the amount of space that we have to have quote unquote natural processes is diminished relative to the native system. So that means if we can design and engineer systems to be hyper functioning on a per unit basis, that would be very beneficial. And so here's an example of that. This is a little bit of a complex figure. Sorry about that. But you can see on the left, the old way of dealing with stormwater runoff, you just dump it in the stream. And in the 1970s, in the northeastern United States, we had a hurricane, caused all kinds of flooding. And so engineers came up with the idea of, okay, we can build these retention ponds, and we could slowly bring the water back into the soil in these retention ponds after a big event. That sort of a thing. And those size of those boxes suggest where that water would end up going. And in this case, it goes right into groundwater pretty quickly. But if there's two big events after another, that system greatly gets diminished in its effectiveness. Then we have on the right, where we add more vegetation, we engineer the soils, and we have what we call green water. So this is water that the vegetation takes up, evapotranspires that back into the atmosphere, increasing pore space for the next event in the soil, and so on and so forth. So the boxes get bigger. And so we think of green water, we have brown water, that's water that's stored in the soil, and then we have the blue water that goes to groundwater. And these boxes are way bigger than what was there before, and probably as good as the native system it replaced, maybe even better, depending on how we design these things. So we can engineer and design hyper multifunctional landscapes. And so the advantages of this is that it avoids those side effects I talked about before. It utilizes biological processes, which are essentially self-maintaining. It preserves function of pre-existing ecosystems. And it works in tandem and provides multifunction in these systems. So the big question then is, how do we then address this in urban landscapes? I can't. Yeah, that's just so. How do we determine on a very heterogeneous landscape what kinds of practices that we could work with to bring back these multi-functioning landscapes, but also hyper-functioning whenever we can do it? And so when I look at urban landscapes, I think of a mosaic of patches of different land use types. Humans like to delineate the boundaries of their ownership of their land. And so much of what we do in the landscape is within those boundaries, or it could be benign neglect, like a remnant patch of forest. Whatever the case may be, it's a very patchy environment. It's a result. And we get all kinds of soil conditions within that landscape, which I call a new heterogeneity. Because soil scientists, when they map soils in the natural environment, they can do a pretty good job of predicting what the soils are going to be like, giving slope, position, parent material, and so on and so forth. It's very difficult to do in a landscape dominated by humans, where the humans are doing their thing on that landscape. So I call it a new heterogeneity, and we're trying to figure it out, basically. And it forms an urban soil continuum, so we can think of that landscape of having different soil conditions at the patch scale primarily. And these can go from undisturbed to less disturbed to entirely engineered systems. And I just want to give you the idea that the point here is that as we develop soil BMPs, we have to develop them within the context of that continuum that we find in the landscape. And again, it's very patchy, so that's a good thing, because we can use a BMP at a patch scale, and we can expect, we can predict what those results would be pretty easily, actually. So just to give you an example of how variable things can be in an urban landscape, this is data from Baltimore City, and not getting into how we did this and everything too much. I just wanted to show you the values on the right for bulk density, pH, potassium, calcium, magnesium, phosphorus, and soil organic matter percent. And if you look at the min and max in that landscape, it's huge. It's way more range in values than you'd find in a similar sized forest. So we are introducing a lot of variability in these landscapes, but again, it's at the patch scale. Some patches, like a lawn, you're not going to find very much variability within that patch as you would in a forest of the same size patch, if that makes any sense. So where do we start then when we're thinking about developing BMPs for a city, for soils? And we need to start with the big picture. We need to look at the whole landscape to get an idea of what the extent of the problem might be, what problems exist. It gives you an idea of how you can prioritize so you get the biggest bang for your buck. And then you can start looking for available BMPs that exist that have been used elsewhere or even locally to cover those existing issues. And so LA is very fortunate to have an urban soil survey. There aren't many cities in the world that have a soil survey conducted for them. And LA is actually has one of the better ones in my view. And so by utilizing this soil survey, I'm not going to get into how they did it and all that stuff. Don't have time. We could talk about that later, but nonetheless, there's this wonderful survey that exists for the city. I think it's underutilized. I think we need to do more with it because they've gone out and collected incredible amounts of information, useful information. And so you're all very fortunate to have a soil survey for your city because not many cities have that. But and to give you an example, so we've actually, we're able to locate 40 samples, soil samples from the Forest Service that were collected in forest plots that had been set up in the LA region. And we were able to run these samples thanks to G. Reese et al. for doing that for us. And again, in that red box, I don't want to go through all the values, but just to point out that, again, there's a wide range like we had in Baltimore. And the other thing is some of those values are pretty darn high. And so there is contamination that exists in this landscape. Obviously, 39 samples ain't enough to cover all the variation that's out there. But this is a clue that on a citywide scale, we might have an issue here. And that's what I'm talking about, the big picture. And I just want to give you an example for Baltimore. And Kirsten Schwartz is going to give a talk later on. Kudos to her. This was her graduate work, where she collected made thousands of readings of soil lead levels at the surface of the soil using X-ray diffraction techniques. And we also did some sampling to go along with that. She was able to, without getting into the details, develop a statistical model that can predict the amount of lead in the surface of these soils. And this map is a result of predictions that exceeded the 400 parts per million in soil that the EPA has. And so you see a lot of red on that map. We're not even close to having this kind of information for LA yet. And so this is the kind of thing that you have to do for that big picture if you really want to get at it. And again, that's the new heterogeneity I was talking about before. So what all this suggests that as we develop these BMPs, there's a big need for individual site assessments. You know, we can make predictions about how bad things are out there, but very specific locations of where you might have lead contamination or problems with infiltration, you're really going to have to go out there and do the site assessment. And so we need to consider the intended use, the community needs and concerns, site-specific soil characteristics, and best to involve the community in collecting that information whenever you can. So we call that community science. The old term is citizen science. And just to give you an example of how these things can surprise you, it might not end up in something that you would expect. In Baltimore, we looked at vacant lots, and vacant lots ended up having lots of coarse fragments, and therefore there's a huge pore volume in those soils, and they can go pretty deep. But we also found out, thanks to Kirsten's work and others, there's a high chance for contamination. And so if you're going to develop a BMP, you're not going to want to increase infiltration rates in these vacant lots. Mainly because it's already high. So the idea would be actually maybe to reduce the infiltration because that's contaminating potential contamination of the groundwater system. So that's just an example of why we really need to think about these things on a site-by-site basis. So it brings us to, and you saw this figure before, there we have we're developing a ensemble of best management practices for LA, and we're defining a best management practice in an urban context as a practice or combination of practices that is determined to be an effective and practical means of promoting urban soil health. I'm not going to go through all this, you know, contamination, quantity or soil volume, so on and so forth, just to say that we're using this system here to organize BMPs that are potentially used in the landscape, that can be potentially used in the landscape. And so we can think of these ensembles as a cookbook, you know, a cookbook of things that a manager can use in the field to address a particular issue that the community might be concerned about, and so on and so forth. And then we need to demonstrate that these things work for this region of Southern California, and also for the intended uses that are, again, very site specific. And so, like I said, it's analogous to a cookbook of recipes, which can be modified to adjust to the region and soil condition on the site. My wife loves to cook. She uses recipes all the time, and she loves to tinker with those recipes. So we're talking about tinkering here that could make the difference of a really nice meal and one that isn't all that great. And they also can be adjusted to specific site conditions, such as high altitude adjustments for making muffins. So that's a picture of a muffins that were made at high altitude, but they did not adjust the recipe for the lower air pressure, which makes a difference when you're baking those muffins. And so what we'd like to be able to do is this ensemble that we're coming up with is actually to get them very site specific and also catered to the region of Southern California and LA. And also for the community concerns that come out. And so Dustin brought this out and this figure out before. So we're systematically going through this kind of a work through already developed BMPs that address these core soil issues that come out of this matrix. And you're going to hear about some examples of these in the rest of the symposium. And I'm going to end there. I want to leave some time for questions. I talked a little fast, I usually do, but I did want to have a discussion if there's time for that.